and welcome to this video on annuities. We have that an annuity is a series of payments, usually in equal amounts, that are made at regular intervals for a fixed period of time. Let's consider the example we have right here, where Michelle invested $1,200 at the end of every month into a registered retirement savings plan for 8 years. The interest rate earned was 5.2% compounded semi-annually for the first 3 years and changed to 4.3% compounded monthly for the next 5 years. The question is, what was the accumulated value of the RRSP at the end of 8 years? So in this problem, we need to work with multiple variables, and we have an annuity that changes type, as we will see. So the term of this annuity is 8 years. So let's try to draw a timeline. And here's the present, so now, and here we have 8 years. What happens 8 years later? Now, because Michelle makes payments at the end of each payment period, the payment period is like here, 1 month, we have an ordinary annuity. Ordinary annuities are annuities that satisfy that payments are made at the end of each payment period. Here, the payment period or payment term is 1 month all along the 8 years. Now, during the first 3 years, so here we have 3 years, interest is compounded semi-annually. That means twice a year. Because the compounding period is not the same as the payment period during the first 3 years, we have an ordinary general annuity for the period between now and 3 years from now. We have an ordinary general as opposed to simple annuity from now until 3 years later. During those first 3 years, the compounding period is 6 months. So the compounding period is 6 months. Because the compounding period, and the payment period are not the same, we can say that the annuity is a general annuity during the first 3 years. But then, for the next 5 years, the interest changes, but interest is compounded monthly. So for the last 5 years, the compounding period is 1 month. And that coincides with the payment period. So for the next 5 years, what we have is an ordinary, simple annuity. Okay. So, okay. Now, let's talk about more variables we need to work with this problem. The $1,200 are the amount of the periodic payment of the annuity. So all along we have that PMT. Remember, this is what we use for the amount of the periodic payment is $1,200. And that should be 1,200. So let's write 1,200. Now, we have other variables to play with. During the first 3 years, what we have is that the term of that ordinary general annuity is 3. While for the next 5 years, the term of that ordinary simple annuity is 5. So we have different terms here. Because we have different types of annuity, we need to distinguish between the two time periods. We have a value for the term of the annuity for the first 3 years, and we have a value for the term of the annuity for the last 5 years. Now, the number of payments per year doesn't change because Michelle invests a certain amount of money at the end of every month throughout the 8 years. So here, the number of payments per year is common. The number of payments per year is 12. So that's another thing that the two time periods have in common. Let me move this a little bit to make room. And there we have that. However, the interest rates are changing. So let me write what things have in common here. And then below we have the things that are changing. For the first 3 years, the interest rate was 5.2% compounded semi-annually. 5.2% compounded semi-annually corresponds to I equals 5.2% divided by 2. The periodic interest rate corresponding to 5.2% compounded semi-annually is 5.2% divided by 2. And that value is the same as 2.6%, or in decimals 0.026. On the other hand, for the next 5 years, the nominal interest rate changes to 4.3%, and then the compounding frequency changes because now interest is compounded monthly. So the interest rate, the periodic interest rate for the 5 years, the last 5 years, is 4.3% divided by 12. And when we do 4.3% divided by 12, we get whatever that is. In decimals will be about 0.003583. There are some numbers afterwards. Okay. So notice that interest rates are different. Okay. Now, what we're going to do, so before we go into more details, let's explain what the general idea of this problem is. I'm trying to draw the timeline so that we explain the general idea. And then we do all the calculations. Now, when we are working with an ordinary general annuity, we need to work with some extra variables. We need to work with the number of compounding periods per payment period, because the compounding period is not equal to the payment period. And we need to come up with an equivalent periodic interest rate per payment period. We will get into those details shortly. But essentially, what we're going to do is we're going to use certain formula for the variable C, that would be the number of compounding periods per payment period. And then we get an equivalent periodic interest rate per payment period. So that will be a new I. With that new I, what we're going to find is the value of the annuity after 3 years. So we will see how much the annuity is worth after 3 years. Let's call that value future value 1. After we find the value of the annuity after the first 3 years, we will need to compute the future value of that future value. I know it sounds like a riddle, but it's just the way it is. After 5 more years, because money doesn't sit just like that. The value of money changes as time passes. So we will take that future value 1, the value of the annuity after 3 years, and we're going to find the value of that amount of money after 5 more years using formulas for compounded interest. So we use compounded interest to find future value 2, the value of the annuity after the 8 years. So here's a 2-step process. First, we find the future value of the annuity after 3 years, the first 3 years, and then we find the future value of that future value after 5 more years pass. And then what we're going to do is we're going to cover this period, this 5-year period, because in those last 5 years, Michelle is investing more money every month. So here we're going to find a future value 3. That's going to be the value of the annuity from the 3rd year to the 5th year. And we're going to find that future value 3 using formulas from ordinary simple annuity, from the section on ordinary simple annuities. So the final answer to this problem is going to be future value 2 plus future value 3. That's what the final answer to this problem is going to be. Okay, now that we have explained the big picture, let's go into the math. So let's do all the math, but I hope you're getting a clear idea of what we're going to do. If you have questions, just write comments or contact me. I will try to help you. But I think I explained what we're going to do and what has in the first part of this video. Okay, so this is going to be the final answer. Let's get to the numbers. So to find future value 1, we work with an ordinary general annuity. So let me erase here. And I'm just going to select and then magically erase everything. Okay, so let's find future value 1. So the term of the annuity is 3 years. For the first 3 years, we have that those 3 years is the time of the annuity. The amount of the periodic payment is $1,200. We have that the number of payments per year is 12. That was common to both time intervals. And then we have based on that number of payments per year. That N is the total number of payments during the term of the annuity. We multiply the number of payments per year by the time period in years. We're covering the first 3 years, so we get 36. The nominal interest rate, remember, is 5.2, and we found the corresponding periodic interest rate. And that periodic interest rate was, I believe, 0.026. And then, okay. Now, because during the first 3 years we're working with an ordinary general annuity, we need to work with the variable C. That is the number of compounding periods per payment period. And we find the number of compounding periods, that's 2 because interest is compounded semi-annually, divided by the number of payment periods, so that's 12. And then what we have with this C is that the equivalent periodic rate that matches the payment period is I2 equals 1 plus I to the C minus 1. So we have 1 plus 0.026 to the 2 over 12 minus 1. And when we use a calculator to compute this, we find the value 0.004287, approximately equal to that. Okay. With that equivalent periodic rate, we can then find the future value of the annuity by multiplying PMT by 1 plus that second periodic rate to the N. Take away 1 divided by that equivalent periodic rate. So in our case, we're finding the value 1200 multiplied by 1 plus about 0.004287 to the 36, take away 1, and then this gets divided by 0.004287. So we find that, and this value is approximately equal to 46,604.26, 44, etc. Okay. Now, after we find future value 1, remember we need to find future value 2, because money, the time value of money is important. Taking that into account is important. We need to find the future value of those 46,000 something dollars after 5 years pass. As I explained in the beginning of this video, we need to find FV2. And to find FV2, we use compounded interest. Future value 2 corresponds to the future value of future value 1. Taking into account that for the next 5 years, interest is 4.3% compounded monthly. So we have 1 plus 0.043 compounded monthly, so then divided by 12. And then raised to the, and we have 12 compounding periods in 5 years, so that is 60. So what we find is 46,604.2644 and some other digits times 1 plus 0.003583. That's what we get out of the division right here. Raised to the 60, and that turns out to be 57,760.64573 and some other values. So there is future value 2. Okay. Now, we need to find future value 3. If you're wondering about what future value 3 is, just go back a little bit and look at the introduction to the solution to this problem. Future value 3 is the future value of the annuity, the one that is for the last 5 years. So that is an ordinary simple annuity. We have t equals 5 in that case. The amount of the periodic payment is still $1,200. Now the number of payments per year is still 12. But now we have n equals, and then we have 12 payments per year for 5 years, so there is 60. And the interest rate is 4.3% compounded monthly. We have this same number right here. So it's 0.043 divided by 12. We get about 0.003583. Okay. So there we have that. And because we're working with a simple annuity, there is no need to find an equivalent periodic rate because the compounding period is the same as the payment period. So future value 3 comes from doing amount of the periodic payment of the annuity multiplied by 1 plus I to the n minus 1 over I, where I is this value right here. So we're working with 1,200 multiplied by 1 plus about 0.003583 to the 60 minus 1 divided by 0.003583. And future value 3 is approximately equal to $80,166.31. There are more numbers afterwards. Okay. And then the final answer to this problem is future value 2 plus future value 3. So we add this number and this number. Wait a minute, not this number. Future value 2 is this one. Okay. So we add $57,760.64 blah 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 and $80,166.314 blah blah blah. And what we get is something we can round off to 2 decimal places. So we have 137,926.96 when we round to the nearest cent. Okay, so that's the end of this problem. Summarizing what we did is kind of long, but I would try to summarize it. Let's see, we have an annuity that changes type. We have a it's ordinary all along, but the first 3 years the annuity is general, while the last 5 years the annuity is simple. We use formulas for ordinary general annuities to compute the value of the annuity the first 3 years, after the first 3 years. And then because 5 more years need to pass, we compute the future value of that future value using compounded interest. And then to cover the last 5 years, we use formulas from the section on ordinary simple annuities. And then we add future values up, the future value of the annuity, the future value of the annuity, and then this future value of the second part of the annuity. When we add those numbers up, we get $137,926.96, approximately that amount. Okay, if you have questions, please write comments or contact me and I will try to help you. Thank you for watching.